know this is a view that you miss. Walking up to room 919, coming around the corner, and saying, let's do some math. So at this point, if we take a look here, what we've done up to this point with 7.5 and 7.6, this week we're stepping into chapter 7.7, is we start off with just basic FOIL. If we looked at it, we could tell, all right, something times something's going to be x squared. We know that's going to be x squared. It's going to be x times x. Trying to figure out times what times 4, what times what's going to be 4. That's also going to equal 5. We can see 1 and 4 can add together to make 5. So we put the 1 right there. We put the 4 right there, and it's plus. That's where we started off. Then all of a sudden, we take a look at the next types of problems that we're looking at. And so for here, we had something last week, 3x plus 15x plus 12. We have a number in front, right? That's really the big change. Is all of a sudden there's a number in front, got a little more work here. First thing we're going to do, trying to be lazy, is can we go ahead, if there's a 3 here, is there a common factor of 3 that we can pull out of this whole thing? And then this factor is, because 3 times 1 is 3, 3 times 5 is 15, and 3 times 4, so we can pull out a 3. And I strategically chose these numbers so this would work out. So I pull out a 3, then I'm left with just 3, or just x squared, because 3 times x squared is my 3x. I pull out a 3 from 15, so now I'm left with just 5, because 3 times 5 is 15. And then I'm left with a 4, because 3 times 4 is 12, right? So 12 times 3, I could pull out a 3. And so in this case, this is now something that, like we just saw right there, this could break down. So I'm left with, I bring down my 3, x, right, plus 1 times x plus 4. And so at this point, right, we're factoring these out as far as we can. If they don't have something, if there was some other number other than 3 here that couldn't pull out, then we just have to start going through, looking at all the options. As you saw on, I think it was page 392, 393, showed these problems. It could be a lot of work trying to go through and do that. We showed you a short little cut that always works out called that Kung Fu method, the guy called it, which again just drops this first number and goes through a process of then multiplying times the last number, and this whole thing will work out. But either way, how you do that, you'll come out with an answer. Always use photomath as you're doing this to double check your answers, but again, kind of go through the struggle of figuring out what the answer is so you know how to do it. So again, whether it's going through every single option or using that Kung Fu method, which again are all both on last week's YouTube lesson that I did for you, go ahead and use those. So now we're going to step into 7.7, which is trying to look for some kind of pattern and saying, okay, if we can't do this, we can't do this, is there some kind of pattern we can see to it that's going to help us? Again, try to figure out what the answer is. Again, it's not always going to work, but we're looking for little strategies to factor these things if it's not as simple as this right here. So now 7.7. So for this first example, I kind of want to show you where the actual formula comes from. They show you a formula there on page 398. And it comes from something we've already done, which is, again, FOIL, just going backwards. But again, we're looking for patterns when we look at this. So again, if we're able to pull out a number, right, that's going to make it easier. Looking at all the different options takes a while, so we try to kind of show you a shortcut, which still comes down to that Kung Fu method. So let's take a look and let's see where on page 398, the example number 1, the formula that they have, or 398 at the top there. Right, if we take FOIL and we go a times a, we're going to get a squared. All right, so if we multiply it out, we're going to come out with a squared. Now, if we do the last two, right, b times b, we're going to come out with negative b squared. And I don't know if you noticed, but when you have opposite signs here, right, this one's positive and this one's negative, they're going to basically cancel each other out, right? Because a times b is going to be positive ab, and a times negative b is going to be negative ab, and they will cancel each other out no matter what the numbers are, or letters, or variables in these actual spots on this expression. So when we do that, right, all that's left over when we finally do this in every single case, when these cancel out, is just a squared and b squared, and everything else will cancel out. So we're left with a squared minus b squared. So if we had actual numbers here, we don't even have to worry about what's in the middle. We just take whatever's in the very front, we square it, whatever's in the back, and we square it. And so when we bring this all together, it becomes, right, I'm going to use an example here, right? This is my a squared, right? So we're going to have a squared, and then it's minus, right? This is my b squared right here. All right, so again, no matter what we have in for a and b, this is always going to work. So if you take a look on example number 1, right, if we can always look at numbers, and the thing that's usually going to cue us off to trying to use this method is if we see things that are nice perfect squares. 1 times 1 is 1, so if we see 1. 2 times 2 is 4, so if we see 4. 3 times 3 is 9, so if we see 9. 4 times 4 is 16. 5 times 5 is 25. So if we see perfect squares in here, sometimes it's going to lead us to scratch our head and say maybe it has something to do with what's called the difference of the squares, because difference means subtraction, and we have a square here, so we're finding the difference. And again, all we have to worry about in the original problem is what is A and B, and we find the difference because the middle part's going to cancel itself out no matter what the numbers are. So if we can always look at numbers and see that they are a square of something, then we may be able to onto a way to solve this. If we look at that first example, or not even the first example, just above that where they have the key concepts or the core concepts, right? If we're looking at that one, if they had some number, right, they have x squared. So if we have x squared, right, we can think of that as our A. If we think of 9, because they have 9 there, 9 can be written as 3 squared, right? So it's 9. And so if I had to, right, if I had to go ahead and actually solve this, we're going to see that this is the kind of situation we're looking at, where we have 9 can be changed into a perfect square. This is x, which is already into a perfect square. And we can actually move backwards now and try to figure out if this is our answer that they're giving us, and I'm working backwards, what's going to go right up here when I put these into their appropriate spots. Well, right, if my a squared, if this form that they're showing us is a squared minus b squared, if it's in this form, we can just work backwards. If instead of doing FOIL and getting the answer, remember what we're doing now is we have the answer and we're moving backwards, right, to FOIL, right? My first one is my A. If I can just come in here, right, and this would be x and x, right? And my B is going to be 3 because we're looking for what's squared, so I could put 3 here for B. And again, right, this is my B in that second position right there. Right, that's my B, so I'm just going to go ahead and put B in, right, for both these. So 3 there, right, and 3 there. And I just worked backwards and I got the answer. And if you think about it, right, x times x is going to be x squared. 3 times 3, right, squared is right there is my 9. The two middle ones cancel because 3 times x is 3x. 3 times negative, or x times negative 3 is negative 3x, and so they cancel each other out. So again, if my original problem is in this form, I can, like Jeopardy, work backwards to figure out what I FOILed to do it. Again, looking at my A and my B and putting them into those places right there. We're going to go through, do a couple examples here for you, and then we'll give you a few to practice on your own down on the bottom. So if we take the example we just did, right, and we're starting off with the answer. We're trying to figure out what do we FOIL to get that, or we're doing factoring is what this is called. Right, A times A is going to be my A squared, B times B is my B squared, the middles cancel out. So for example A on number 1 on page 398, we're going to take a look, right? So we can put in a form where it's something squared and it fits that. That may get us in some kind of direction we can do something here. Again, if it's easy to FOIL just by looking at it, just do it. If we can pull out a number, we just do that. However, sometimes we get certain cases where we can't do either of those, but we can look at it and say, wait, I notice a pattern here. If it's in this form where something's squared and squared, I can put it into this form here, just working backwards. So for example A, they have x squared, which again, for A, it's going to be x squared. And then they have 25 here. 25 can be written as 5 squared, right? 5 times 5 is 25. And for my A, that's in that position here, it is my x squared. All right, and so again, knowing that this is my A and this is my B, if I work backwards, I can just fill them in back here and figure out, right, what was the original thing that I multiplied to get this here, right? What are my factors? So, right, if A is going to be x, then again, I can just remove these off here, and if it wiped off, I'll fix that there. And then this is my A, because it's also x. All right, so again, my x, right, is my A in place here. My B, I'm just going to replace it in there, because that's what I'm multiplying. Again, it's squared. B times B is B squared, and B is 5. So if I go ahead and remove, right, B is 5, and B is 5 right there, right? And so I'm left with x times x is x squared. 5 times negative 5 is my negative 5, or minus 5 squared, or 25, because 5 is my B. And then the middles are going to cancel out. 5 times a positive 5x, negative 5x, they cancel each other out. And so that is my FOIL right there, right? That's my factoring that went backward. This is what I'd FOIL to get this answer. This is what I'd factor to get that answer. So again, I'm working backwards. So usually they're giving you to this form. You're trying to work backwards like we've been doing up to this point. This is called the difference of squares, because these are squared, and it's the difference between the two squares. You don't have to do anything other than figure out what's your A, what's your B, plug it in, And again, if you don't believe it, work backwards, and you should come out with the exact same answer. All right, for part B on example number 1, we're going to take a look. Again, all we're looking for is there some way, right, to set up in this form where we have something squared and something squared, and I can plug it in going backwards, knowing that this is, right, the answer to this one. So, right, if I take a look, and for this one we have 4x, right, and it's squared. And we can think of, right, well, this is 4 and then this is 1 over here. We can think of 4 as 2 to the second power, right? So that kind of leads us on to thinking that maybe we're onto something here, because 1 times 1 is also 1 squared. So that's given us a hint that we may lead in this direction to try to solve this. Again, we're kind of grappling for anything to actually get an answer here. So we take a look, right? 4 could be written as 2 squared, and x squared, right, could be, right, that's x squared. So I can actually think of A as x, right, 2x to the second power, because if I have 2 2's, that's going to be 4. If I have 2 x's, that's my x squared. So that's my first instinct that I'm going to use this, and this is my A. So I can go backwards, and I can fill this in for my A. For B, I'm trying to figure out what times what is 1. Well, I can write that as 1 squared, right? So again, with 1 squared, right, I can set this thing up where 2 times 2 is 4, my x squared, right? Now I can go backwards and fill these in, right, appropriately into this original FOIL that I did, because again, I'm trying to factor this. So if I take, this is my A, as we just remembered, right? This is my A squared. This is my A. I'm just going to come up here and put 2x and, right, 2x. Right? If this is my B, because this is my B squared, I'm just going to come on up here and I'm going to put it in, right, 1 and 1. And that is my actual factoring of this original problem. So again, we FOIL to get this, we do this, right, we factor it. So we take a look. 2 times 2x is going to be my original 4x squared. 1 times 1, negative 1 is going to be my minus 1, my original problem. The 2 middles are going to cancel because 1 times 2 is positive 2x. 1 times minus, or 2x minus times negative or minus 1 is negative. So the opposite in the subtraction and the addition subtract each other, they cancel each other out. So again, it leads us to being able to use this differences of squares to get this answer. We're going to let you try a few more on the bottom. You'll see, I think, for example number 2, kind of the same thing's going on. You have 2 sets of numbers that are squared. You're just plugging them in for A and for B, but you're doing it with actual hardcore numbers, right? So we're going to let you try also example number 2 and a few problems to actually practice with that one. Tomorrow, we'll go on to examples number 3 and 4. So today, for this here, this is enough, bite size. Remember, we're not trying to kill you. A little bit each day. Do the practices. Actually go through and try to do them. Again, you can use photo math, but again, if you're doing that to do the answer, not as good as doing the problem, struggling through it, and then figuring out if your answer is done correctly, right? So again, all for you. We'll make sure you got this.